we're going to look at justifying solving inequality, which is exactly like an equation. So yesterday we talked about inequality symbols. So remember, those are the symbols that look like this. So we'll be seeing these inside of our equations instead of equal signs. So when solving an inequality, it's just like solving an equation. We still follow the same 5-step questions that we go through, and we still use the same properties as before. Now, the only difference is when we are multiplying or dividing by a negative. When we multiply or divide by a negative, we must flip the inequality sign. So we'll show you an example right here. So let's say we're working on a problem and we get down to this as our final step, negative 2x less than or equal to 8. In order to solve for x, we have to divide by a negative 2. Now, first thing that I want to talk about is that this side would be considered our smaller side. So it has some sort of negative symbol going on over here. Whereas this side is a positive 8 and it is the bigger side. So on this side, we're dealing with a smaller number. This one, we're dealing with bigger number, negative, positive. When we divide by a negative 2, what that does is it cancels out our 2's and we're left with 1x. So now this became a positive, right? Over here, 8 divided by negative 2, that is a negative 4. So what happens when we divide by a negative, it switches the signs on each side, right? So this negative side became positive, this positive became negative, which means this symbol right here doesn't make it sense anymore. A positive cannot be less than or equal to a negative. So when we're dividing by a negative, we're flipping the signs of both sides, which means we literally need to flip our sign. Now, the reason we didn't do this before is because an equal sign, let's say we have an equal sign, if we were to flip that, it would still be an equal sign because it doesn't matter what's on either side, it's equal. With an inequality, that's not the case, and so we need to remember to flip the sign. Now, from here, this would be our final answer. One thing we're also going to be doing is we're going to be writing the number line and interval notation along with our answer. So I always like to start with a number sign or the number line. Visuals, I think, are better in math, especially with this stuff. So we'll always start by making the number line. So our number is at negative 4. So I'm going to find negative 4 right here. And our symbol is an equal to, which means a closed dot. And our x's are greater, so to the right where the greater numbers are. So this is my number line representing this inequality. Now we are going to do interval notation. So remember, interval notation, we read from left to right of the number line. So on my number line, the left-hand side starts at negative 4, and the right-hand side goes to a positive infinity. So negative 4 to infinity. And now we just have to remember our symbols. If it is a closed dot, it is a bracket. If it is an infinity symbol, it will always have parentheses. So that is our interval notation. Now, when it comes to flipping signs, we also see it in one other scenario, which is with our symmetric property. When we're using symmetric property, we must also flip the sign. And again, it follows the same reasoning as before. If this is my final answer, 8 is greater than x, I need to flip this around so that x is in front for our formal answer. Now, in this problem, it was saying that 8 is greater. If I forget to flip my sign, I would now be saying x is greater, which isn't true. That's not what this is saying here. So I need to make sure I flip my sign so that it is still opening to the greater value, which was 8. So now for our number line, we have the value of 8, which is right here, and it is going to have an open dot because there's no equal to. And we're shading all the numbers less. Remember, the shading represents all the representations of x, so it's saying x is less than 8, so I'm to the left, the lower numbers. Interval notation, remember we read left to right, so on my number line, the shaded region starting at the left, it's going to negative infinity. That arrow means it goes on for forever, and it ends at 8, and then infinities have parentheses. 8 is an open dot because it's not included, so it has a parentheses as well. So what we're going to do now is just apply what we learned before solving the equations, and we're going to start very, very simple with a one-step equation. So here I have negative 4n is less than or equal to 8. I need to divide by negative 4 This will cancel, and I'm left with n. 8 divided by -4, -2. Now this is where our rule comes into play. Before, we're dividing by a negative number, which means we flip the sign. And then our justification is that we use division property of equality. Remember, if there is a equal sign or a symbol, that's where we write the property. If it's scratch work, nothing goes there. So now on the number line, we have n is greater than -2. So I'm going to go to -2 and draw an open dot because there's no equal to. Greater is to the right, so I'm going to shade to the right. For my interval, we read from left to right. On the left, we're starting at -2. And at the right, it's going to infinity according to that arrow. -2 is open, so we use parentheses. Infinity, always parentheses. So next one, 15 is greater than or equal to 5r. So 5r we want to get by itself, so we are going to divide by 5. And remember, when we're using justifications, one thing we have to remember is whatever is left comes straight down. We're not allowed to flip yet because we have a property for that. So we have to do one at a time. So I'm going to bring this down. I don't have to flip my symbol because I'm dividing by positive. Nothing changes. So 3 is greater than r. And I got that by division property of equality. And now I need to flip around so that r is in front. And when I flip, what I need to remember is this was opening to 3. It still needs to open 3 to 3 because 3 is greater. That is symmetric property. Okay. Now on the number line, r is less than or equal to 3. I'm going to go to 3 and mark it with a closed dot because of that equal sign. And then I'm shading to the left because it is less than. So my interval notation starting at the left-hand side, we are starting at -infinity. And we are shading all the way to 3. That 3 is closed, so it's a bracket. And remember, infinities always have parentheses. All right, next one. So we're going to start picking up in difficulty for these. So on this one, remember, first question is, do I distribute? The answer is no. Second question, do I need to clean up? The answer is yes. Right here, there are 2 r's. So -1 and -2 will combine to make -3r. -15 is less than or equal to -3r by combining like terms. R needs to be by itself, so in order to get rid of that -3, I'm going to divide because that was multiplication there. So when I divide, I need to be careful because I'm dividing by a negative. So -15 divided by a -3 is a +5, but I need to flip the sign because I'm dividing by negative r. So division property of equality. And now I need to flip. So according to symmetric property, when I flip, I need to flip my sign as well. So in this problem, I have now flipped it twice, one from dividing by negative, 2 because 5 was larger, right? And so it needs to stay larger, symmetric property. So I'm going to do my number line now. I'm going to go to 5. At 5, I'm going to put a closed dot because of the equal signs. Remember, all of this is from your graphic organizer. R is less than, so to the left. And for my interval notation, we're reading left to right. So at the left-hand side, we're at -infinity with our shading. And I shade all the way to the number 5. 5 has a bracket because it is closed. Infinities always have parentheses. So next one I'll do with you, and then I'll let you try one on your own. So again, we're starting with combining like terms, 5n and 2n. That is going to be 7n. 0 comes down, combining like terms. Now I need to divide by 7 to get n by itself. 0 divided by anything is 0. And then n comes down, division property of equality. Now notice I did not flip the sign, and that's because I divided by a +7, so everything will stay the same. But now that I have to flip this around for symmetric property, n is greater than or equal to 0. I do have to flip that sign because n is the greater value, so it needs to stay the greater value. So symmetric property. I'm going to go to 0. and do a closed dot because of the equal to, and this is saying n is greater than 0, so I'm going to shade to the right the greater values. Reading from left to right, my shading starts at 0 and it goes all the way to a positive infinity on the right. 0 will have a bracket because of the closed dot. Arrow is infinity, so parentheses. All right, so next one I want you guys to try 5 on your own. So pause the video and then check it when you are done. Okay, so just like the ones before, we are going to combine like terms. So I have 8x minus x, which is 7x. I'm going to bring everything else down, combine like terms. Now I need to divide by a 7 to get x by itself. Now I'm dividing by a positive 7, so the sign stays the same. Negative 21 divided by 7, negative 3, division property of equality. I'm going to flip with symmetric property. And when I flip, I need to make sure I change the sign because x was greater. It is going to stay greater. So at negative 3 is where I'm going to draw my dot. So this is negative 1, negative 2, negative 3. Close dot, greater to the right. And then my interval notation, negative 3 to infinity. Negative 3 is a bracket. Infinity is parentheses. All right, so I'll do one more. I'm going to have you guys try this one on your own as well. So a little bit different. We're going to start with distribution first. So go ahead and try number 6 on your own and then check with the video. Okay, so distribution. 4 times 3 is going to give me 12. 4 times negative 6. Negative 24p is greater than or equal to 156. Distributive property. We do not have to clean up. These are not like terms. This is a constant. This has variables, so we're going to move on. I do not have variables on both sides, so I don't need to take care of that. So I'm just going to work on isolating. So p is on the left-hand side, which means I need to get rid of these numbers that are with p. So I'm going to start by getting rid of the weakest operation, which is this plus or positive 12. So I'm going to get rid of that by subtracting 12 from both sides. Negative 24p is greater than or equal to 144. So I get that by subtraction property of equality. Now I need to divide, and we have to be careful here, so hopefully we caught this. We are dividing by a negative 24. So this becomes positive p, and then 144 is going to become a negative value. So that is going to be the number 6, negative 6. And because I'm dividing by a negative, this sign now needs to flip. So it's a less than or equal to, and I got that by division property of equality. So at negative 6, that would be right here. I'm going to put a solid dot, close circle, and shade to the left. And then reading my number line, we are starting at negative infinity, and we are shading all the way to negative 6. Negative 6 is a bracket because it is closed. Infinities always have parentheses. Okay, so that is it. We are going to pick up with the rest of the notes tomorrow. So we'll just do a couple of these tomorrow. So leave these blank, and that is it.